This is monosodium glutamate, the molecule that has sparked debate for centuries. Some people say it's a dangerous additive, while others swear by it for that savory meaty taste, the umami. I'm not here to debate about whether monosodium glutamate is safe or not. I mean, I do agree that there are individuals that are sensitive to monosodium glutamate, but come on, if people that are allergic to water do exist, then it's not surprising that there's somebody out there that is allergic to monosodium glutamate. I know a lot of you are going to say large amounts of monosodium glutamate are not safe for everyone. And yes, you are right. You are very correct. But how much is large? That large is more than 3 grams of monosodium glutamate on its own without any food within 24 hours. Who in the right frame of mind would take 3 grams of monosodium glutamate and swallow it? Or should I say lick it? What level of stupidity would make you do that? Anyway, like I said, I'm not here for the debate. I'm here to talk about the structure of monosodium glutamate and how it brings about the umami taste. So let's get into it. Monosodium glutamate is the sodium salt of glutamic acid, an amino acid your body already makes. It's made up of sodium cation. This is the sodium cation, and a glutamate anion. This whole thing is glutamate anion. The glutamate anion consists of 3 key functional groups, each of which plays a crucial role in bringing about the umami taste. Right here we have the carboxylic acid group, which is responsible for the acidic character of monosodium glutamate. And here we have the carboxylate group, which is the deprotonated form of carboxylic acid. The carboxylate group is what actually makes this whole thing to be a salt. Remember, we said it's the salt of glutamic acid. The negative charge on this carboxylate group makes monosodium glutamate to be highly water soluble, thereby allowing it to easily dissolve in food and saliva. Additionally, the carboxylate group interacts with taste receptors through ionic bonding, thereby contributing to the umami taste. As if that is not enough, this carboxylate group, together with the carboxylic acid, helps stabilize the pH of solutions by participating in acid-base reactions in which the carboxylate group acts as a base. This carboxylate group acts as a base, and the carboxylic acid group acts as an acid, like making a buffer solution. Right on this alpha carbon, we have the amine group. The amine group is what makes glutamate to be an amino acid. It mirrors natural amino acids, thereby making it easy for the body to recognize and metabolize monosodium glutamate. The amine group also interacts with taste receptors, the umami taste receptors, especially the T1 ARA1 taste receptors, thereby enhancing flavor perception. The amine group can also bond with water or receptors through hydrogen bonding, thereby bringing about the umami taste. Last but not the least, we have the sodium. What's particularly interesting is the presence of this sodium. This sodium is what differentiates monosodium glutamate from pure glutamic acid. Remember, we said monosodium glutamate is the sodium salt of glutamic acid. So if we were to place hydrogen in place of this sodium, then we're just going to end up with glutamic acid, which we already have because our body naturally produces it. And you might even ask why we actually need this sodium. This sodium helps to enhance the taste and also stabilize the glutamate, which is the flavor enhancing component. I mean, it is the glutamate that is responsible for the umami taste, and this sodium helps to stabilize it, and it also breaks down in water to release this component. They're ionically bonded, so it dissolves in water and separates, or should I say release this glutamate, which we actually need for that umami taste. Thanks for watching. See you next time.